In this video, we take a look at another application, this one involving medications and dosages. When ibuprofen is given for fever to children 6 months of age to 2 years, the usual dose is 5 milligrams per kilogram of body weight when the fever is under 102.5 degrees Fahrenheit. How much medicine would be the usual dose for a 7-month-old child weighing 18 pounds? Note 1 pound is approximately 0.4536 kilograms. Now there are several ways to approach this problem, and the way you solve it may be very different than the way I solve it. But what is my brain telling me to do? Well, first of all, I'm observing that I have some superfluous numbers in here. They give the problem context, but they're not really needed to solve the actual problem. Namely, the fact that it's 102 degrees Fahrenheit is not important, not necessarily. I have a child and 6 months to 2 years, that's important because that corresponds to the 7 months. But really, when it comes down to it, what am I trying to do? I'm trying to take a dosage, which I have right here, 5 milligrams per kilogram, and I have to correspond that dosage to a child that weighs 18 pounds, given that I know 1 pound is 0.4536 kilograms. Those 3 bits of information are really the information that's going to help me solve this problem. Let me start then by writing down that first bit of information, namely that 5 milligrams of medicine, so 5 milligrams of medicine corresponds to 1 kilogram of body weight. And you know what? This is making me think maybe I want to use a proportion here. So 5 milligrams of medicine corresponds to 1 kilogram of body weight in the same fashion as the dosage of X milligrams would correspond to 18 pounds. Right? So we have a child that weighs 18 pounds, but we know what our dosage is, or our relationship for our dosage. Now, in order to solve a proportion, what must be true? Our units must agree. Right now, our numerator is good. We have milligrams on the left and the right corresponding to the medicine. The issue then is the denominator, 1 kilogram versus pounds. We either need to convert both of our units into kilograms in the denominator or both of them into pounds. Based on the information I'm given that 1 pound is 0.4536 kilograms, I am actually tempted to take the pounds right here and convert them into kilograms. Namely, 1 pound is 0.4536 kilograms. So that means 18 pounds has to be 18 times 0.4536 kilograms. That's going to tell me the number of kilograms that 18 pounds is equivalent to. If I pull out my calculator and multiply, I will multiply 18 times 0.4536, and that gives me that the number of kilograms that 18 pounds is equivalent to is 8.1648. That's going to be the relationship I use to set up my proportion. Namely, 5 milligrams of medicine is to 1 kilogram, as X milligrams of medicine is to 8.1648 kilograms of weight. Now I'm set to go ahead and solve. How do we solve? Well, we take that proportion, we cross multiply and divide. So I'm going to cross multiply. Ignore our units, right? So we're going to take 5 and multiply it times 8.1648. And then we're going to take 1 and multiply it times x, or just 1 times x. On the left side, I have 5 times 8.1648, or 40.824, and that equals 1 times x, which is just x. And there we have it. We've actually just solved for x. What was x? X was the number of milligrams, or the dosage of medicine that I needed for a 7-month-old child. I have it finished right here. That tells me that I need 40.824 milligrams, or if we're rounding to the nearest milligram, that would be 41 milligrams of medicine for our 7-month-old child. I can't reiterate enough that there are different ways to solve these problems, and the way my brain works and your brain works might be very different. I am just giving you some tools, some suggestions, some ideas of how you could use dimensional analysis, or in our case, proportions, to solve these problems. If you have any questions at all, please don't hesitate to reach out and contact me.